In the previous lesson, we were talking about line segments and specifically focused on the midpoint of a line segment. But in this video, we are going to focus on the length of a line segment. Remember, there are three things that really should come to you whenever you see a line segment. What's its slope, what's its length, and what's its midpoint. So we know how to find the slope, we know how to find the midpoint, and here we are going to learn how to find the length of a line segment. Okay, so finding the length of a line segment, the formula is actually pretty scary looking, but it's actually very simple. So all you have to remember is the Pythagorean theorem from elementary school. What is the Pythagorean theorem? States that in any right triangle, the length of the hypotenuse squared is equal to the sum of the remaining sides squared. Okay, we usually call those two sides the legs of the right triangle. But what you probably remember is this: a squared plus b squared equals c squared. And once again, you can only apply the Pythagorean theorem if you have a right triangle. Okay, that's pretty important. All right, so now how is that going to help us find the length of a line segment? Okay, let's take a look. I have my beautiful line segment AB here. I have my endpoints labeled, and just like with the midpoint formula, endpoint A, it's x sub 1 and y sub 1 are the coordinates, and for B, my other endpoint has the coordinates of x sub 2 and y sub 2. Okay, and I also wrote down rise and run here. Well, that's what you did in grade 9, right? You find the difference of the y coordinates to give yourself the rise, and then the difference in the x coordinates gives yourself the run. Now, how does this picture help us find the length of the line segment? Well, if you really remove everything here, what do you really have? You have a right triangle, right? So what kind of triangle do you see above? A right triangle. And a right triangle is our good friend. I'm going to cover everything up again. Remember, the goal is to find the length of the line segment. And because this is the right triangle, the length of the line segment is essentially the hypotenuse of the right triangle. The length of the line segment is the hypotenuse of the right triangle. Okay, so that is actually very helpful. The line segment can be seen as the hypotenuse of the triangle. Thus, we could just use the Pythagorean theorem to come up with our formula. So D is for distance, okay? Or you can replace D with L if you don't like D. L would stand for length of the line segment. Well, it's all really, they all mean the same thing. So whatever your preference is. So I'm actually just gonna write the distance from A to B. If I square that, remember it's Pythagorean theorem, right? A squared equals B squared plus C squared. So it's equal to the rise squared plus the run squared, right? This is basically the Pythagorean theorem, right? The two legs are rise and the run. So rise squared and the run squared. It's equal to the hypotenuse squared. Well, the hypotenuse is our line segment here. So what we want to do is square root both sides because we want to isolate the distance or the length of the line segment. So that's how I went from here to here. Okay, and in fact, we're going to take this one step further. Okay, the length of the line segment AB is equal to the square root of, well, what is the rise? What is the run? Well, the rise, I'm actually going to do run squared plus rise squared instead of rise squared plus run squared, because I think most students like to see the x's first and then the y. So the run is x sub 2 minus x sub 1. And what is the rise? Y sub 2 minus y sub 1, right? Run squared plus rise squared. Right? These are just the legs of the right triangle. So like I said, the formula is a little daunting, it's a little scary looking, it looks like it's really hard to memorize, but really, you can just simplify, right? run squared plus rise squared, and then square root that, because you're really just solving for the hypotenuse of a right triangle. So try really not to be intimidated by this. Just think of the Pythagorean theorem. Okay, so that's the formula. So we have a formula to find the midpoint of a line segment, and now we have a formula to find the length of a line segment. And by the way, I generally use L, but the only reason I chose D is because the textbook uses D. So it doesn't really matter if you use D or L on the test or quiz. Both are acceptable. Okay, so let's get some practice in here. Calculate the exact length of the line segments with endpoints -1, 4 and -3, -6. I'm just going to put a B here. Okay, we should really always label our endpoints here. Okay, so we'll do D sub AB, which is the length of the line segment. So I'm going to just copy down the formula first. And this formula is actually very forgiving. You can actually make quite a few mistakes and still end up with the right answer. So just like in grade 9, you label the points. Doesn't matter which one is x sub 1, y sub 1? Absolutely not. So I'll just say this is x sub 1, y sub 1, x sub 2, y sub 2. Oops. All right. So punch away. Let's see here. -3 minus -1. And this one is y sub 2 is -6 minus 4. Ooh, okay. So this is going to be -3 minus -1 is -2, squared is 4. This is -10, squared was 100. This is root 104. Now it says exact. Exact means leave it as root 104. I know that bothers a lot of students, but once you punch in the calculator and find root 104, that is no longer exact. Once you say approximately 10.2, that's approximate. Okay, so we don't want the approximate answer, so just leave it as the square root of 104. And let's just add units here. Bam, done. The length of this line segment with the given endpoints is 1 root of 104 units. Okay, square root of 104 units. All right. On a street map of his town, Alex's house has coordinates of 6, 3, and he has 2 high schools, one at A and one at B. Which school is closer to Alex's house? So what we're going to do is basically this calculation 2 times. We're going to find distance from Alex's house to high school A. Let's see, 6 minus 0. Okay, so that's the run squared. And now it's time to do the rise squared. So this is going to be 36, and this is going to be 25. 36 and 25, that's going to be 61. All right, so distance from Alex's house to the first high school is square root of 61. Well, that's on the map is units, so I don't know how much 1 unit converts to in distant real life, but we have root 61 units. All right, what about his house to the second high school? Let's see, 6 minus 4, and what do we have? 3 minus 9. Okay, so run squared plus rise squared, and then square root that, because you are looking for the hypotenuse, the length of hypotenuse, which is the line segment, length of line segment. Okay, so this is going to be 2 squared is 4, -6 squared is 36. Ooh, pretty close. Since root 40 is less than root 61, therefore Alex's house is closer to high school located at B49. Okay. All right. We have a triangle here. What is the exact perimeter of the triangle with vertices A, B, and C? Okay. All right. So we gotta do a. Really, there's no shortcut. We're just punching in. We're practicing our use of the length formula here. You have to find length of AB, AC, and BC. Right. So AB. So run squared. So it's going to be 7 minus negative 2 plus 8 minus negative 3. Okay, so that's going to be 9 squared is 81. That's going to be 121. 11 squared is 121. So this is going to be 202. All right, let's check. Oops, doesn't matter. We'll do BC first. Makes no difference. All right, BC. So rise. Sorry, I did run actually. Run squared plus rise squared. So it's 8 minus negative 3. Right, 8 minus negative 7. Perfect. Ooh, these are gonna be pretty big. 7 minus negative 6 is 13. 13 squared is 169. 8 minus negative 3 is 11. 11 squared is 121. So this is going to be 290. So square root of 290 units. All right, one more side length and then we're good. You know what I'm going to do down here just to save some space here. Distance. So we got AB, BC. Now we want AC. If you are very uncomfortable with the calculations, what you can do first is plot the points, roughly sketch them out, and then you'll see the triangle. You still have to do all the work here, but at least you see it and you're more comfortable. So you know what? I'm not going to plot the points exactly. -2, negative, so you're in the third quadrant. 7, 8, you're in the first quadrant, and then. Oh, whoops. Let's see. So we're looking something like that, right? Oh, actually, it should be on the same line. They should because they both have a y-coordinate -3. Anyways, I don't care for the accuracy. All I'm saying is, if you feel very uncomfortable with what I'm doing, then just give yourself a diagram and look. You want to find this, the length of this side, the length of this side, the length of this side. And then once you have all 3 sides, how do you find the perimeter? You add them together. Okay, so back on track. AC here. Let's see. -2 minus -6. So this is going to be our run squared. So that give me one of the legs squared. Now the other one, -2 minus -6. So this is going to be -3. This could be 0. Beautiful. So, whoops, this is going to be actually, you know, I won't skip this step, I'll show you. So -2 minus -6 is 4. 4 squared is going to be 16. And I was going to skip this step and just write 4, but you can take your time. All right, so guess what? They want, once again, exact. So therefore, the perimeter of triangle ABC is square root of 202 plus square root of 290 plus 4 units. Okay, so this is the perimeter of triangle ABC, and in this lesson we learned how to find the length of a line segment.